Does this help?
Yes.
Also nice to have you all here without my robot voice.
Gabri, is the repo public already?
Yes, it is public.
Nice.
Yeah, it was just added, so that's cool. And look good.
Okay. Hello, everyone.
Hi. How are you?
Hi. I'm good.
Hi.
I'm good. I'm trying to figure. I've never been on this platform before. I was like, am I on mute? Am I not? But I'm starting to figure it out.
Yeah, for us, the first time was also trial, demo, and these kind of things. But
Yeah.
we are really happy with it. It's cool.
Amazing. Is there? I can't remember if there was an agenda for today. If there's something we're looking over. It's my first time here.
Yeah, so there was a agenda where initially Danny is going to give a brief introduction about Argila, our vision, and the things that we're going to focus on during the coming months, and also introduce our new package for creating synthesizing data sets from LLMs and also synthesizing labels and preference data for LLM. And then after that, Gabri is going to showcase this using our Google Colab notebook and actually sharing this new open source initiative we've been working on over the past couple of weeks.
Amazing. I'm excited.
And also, if there's things that you would like to see discussed for coming meetups, feel free to provide them as input or as suggestion on Slack or in the chat or these kind of things. We try to take them into account. And also, if there's questions or these kind of things, feel free to ask, and we'll try to answer at the best of our knowledge.
Perfect. Thank you so much.
Yeah, and feel free to introduce yourself if you want.
Yeah.
Yeah, I'm Jenny. I'm with Prolific. We've met. I think Danny, you.
Nice. Yeah, now I.
You're like, maybe I recognize her.
Good to see you.
So yeah, I'm just excited to hear more about what you guys are doing and be more proactive in getting to know you guys better.
Nice.
Yeah.
Hi, Ankush.
Hi, all.
Hey, Ankush.
Nice. A lot of familiar faces again. We're gonna wait for maybe some more minutes, Danny, or do you already want to start?
We can wait for a few minutes.
Okay. And Christopher, thank you for the PR, for the update of the small text notebooks. Anyone else that wants to introduce his or herself?
You can go. I'm Louis. I used to work with NLP heavily a few years ago, and now I especially worked with knowledge graphs, and so now I'm thinking about combining knowledge graphs with LLMs and using Argila with Hugging Face and stuff. It's my second meetup.
Yeah, would love to hear something about it. If you want to share one day or in Slack, or feel free to reach out.
It's not really far right now, but I'm catching up on the great work from Neo4j, who's been working in that corner. So I'm really excited. But I hope I have something to show soon.
I'm sure it will be awesome. Yeah. I've heard great things from Paco Lathan. And I think, Ankush, you also knew Louis, no?
Yeah.
Okay.
I know Louis back from Pytex, right? So hi everyone. I'm Ankush. So I've been working in NLP for quite some time. And in my last startup, it was primarily about NLP on academic literature. So yeah, pretty excited. I'm also just catching up with whatever developments are happening on Argila. I look forward to catch up and perhaps contribute also.
Nice, welcome.
So good to see you again. So I guess we can get started?
Yeah.
Okay, cool.
Do you want to give a brief introduction or shall I kick off?
Maybe the agenda, like briefly about what we are going to talk about today, and then I will.
Sure. So today, initially, Danny is going to give a brief introduction about the product version of Argila, and that's going to include the open source package, our cloud ideas, TypeScript package, and also the new package that we're announcing under the name Distilabel. After that, Gabri is going to give a brief overview of the notebook that we've prepared with a brief guide on actually how to use Distilabel, the package that we've created for synthesizing data or distilling knowledge from LLMs, and also creating like a preference data set that you can later on use for fine-tuning for LLMs, for example. So that might be interesting for Louis as well. And yeah, it's really nice to have all of you here. On the bottom right corner, there's this Q&A section thingy that you can press and actually ask questions so that everyone can share and we know and keep track of them. The session is being recorded and we'll share it afterwards. And we'll, throughout the session, also try to share some notebooks and some content and these kind of things that you can actually use to follow along. So then I'll give the stage to Danny.
Cool. Welcome, everyone. So yeah, I'll try to be short because I want to leave space for Gabri to show the actual thing. Let me share my screen. Do you see the presentation?
Yeah.
Yeah, cool. So yeah, there were some questions in the community channel and in private messages about what's our vision for the coming months and for the product. So I prepared this brief deck to show you. So the way we position Argila as a platform is more and more about collaboration, and it's a collaboration between AI engineers, LLM engineers, NLP practitioners, and domain experts, as if you've been following us. And also we are introducing this aspect of AI or machine feedback. And today is actually the kickoff of this new component of the Argila platform that we are really excited to share with you. It's essentially a few pieces of, there's SaaS version of it, which is Argila Cloud, and it's for companies wanting to use that scale and also to forget about actually upgrading, hosting, and all the things that sometimes are not the core of the business of a company. So that's Argila Cloud. And then we have a few other components. The Argila Core is the open source, that's the main repo. And yeah, it has several pieces like the REST API, the UI, and the SDK. That is an important piece for us. And it's essentially a Python library for actually working with datasets, models, and doing something meaningful in order to share this data with domain experts. And the project we are introducing today is called Distilabel, that is based on this idea of distilling knowledge from LLMs. And we got really excited about recent work on Zephyr, this open source model from Hugging Face, also Tulu from Allen AI, that has shown that working with these synthetic data sets for preference data, which is like the data that you need for RLHF and DPO, is actually possible. So we got really excited about this, and we decided to build our own framework to help practitioners to build these data sets efficiently. So we've been working a lot on how to make LLM inference efficient, how to make the AI labeling efficient. And yeah, we will be showing that new project. In a few minutes, I will also share the Hacker News link, and I would really appreciate if you could upvote the post so we can get some visibility. And the other project we are not working on yet, but we will very soon, is Argila JavaScript or TypeScript, and I will be introducing what we mean by that. So Argila Core is this platform, open source platform, to orchestrate human and AI feedback for small and large language models. And that's important for us. We are strong believers of small models. We are strong believers of the need of human curation and intervention. So it's not all about AI feedback, LLMs, and so on. So Argila Cloud is the enterprise version of Argila Core, and it integrates all these ideas into a scalable platform. For now, the only difference with the core is that it's hosted by us, but next year we'll be introducing more enterprise-related features. Distilabel is the open source framework for building labelers and datasets with AI, and you will see that in a second. And argilla-js, this is not started yet, as I said, but it will be a web toolkit that you can use to capture feedback from AI-powered apps. So you can imagine an assistant or like an enterprise application that is using LLMs to help users or to generate content. So you can imagine that you can embed then components to capture feedback directly from those applications and send that data into Argila, so you can have a centralized repo with all the feedback coming from these applications, also from the experiments from the AI team and even from LLMs in production. So argilla-js, essentially that is about sending data, providing web components where you can embed the feedback collection right away in the third-party applications instead of asking all your domain experts or users to go to the Argila core UI to actually work on the human feedback. Distilabel is about building data sets with AI, and we are strong believers that if we enable this and we enable domain experts to go to these AI-generated data sets, we can get huge improvements. And in fact, we will do an announcement next week as well in the LLM space, because we've been building our own model with this idea. So Distilabel briefly is about labelers that are LLMs, can be open source or closed APIs. There are generators that generate responses. Then you have a Hugging Face dataset with inputs, and then you have the concept of a pipeline. And this pipeline orchestrates the generation process. So imagine a Llama 2 model will generate several responses. The labeler will rate or qualify these responses. And at the end, what you will get is a dataset labeled by AI with rationales and explanations about the decisions. And the idea is that you can push this data directly to Argila for leveraging the metadata properties, the sorting mechanisms, and quickly curate this data with the end goal of actually training or fine-tuning or adapting language model. So yeah, briefly, we are covering one task that is essential for RLHF, and that's called the preference task. And this one is about using AI labeler to actually rank or rate several responses, which is the essential piece for the reward modeling or DPO stage, where you actually tell the model what is the preference, in this case from AI, but if you use humans, is the human preference. So why one response is better than the other, and this is going to be used in the fine-tuning or preference tuning process to actually steer the LLM towards the responses that are preferred by humans. And yeah, we've been implementing and exploring many different techniques, but for this release, we cover ultra feedback, that is the data set used by Zephyr. So essentially what we provide is a way to build your own ultra feedback data sets for your own use cases. And we cover some other techniques, principal guided generations and other innovations in the AIF space. And then the other task is self-instruct. So you might know this one from Alpaca. That was like the second work on this line. The other one was called self-instruct. And the idea here is that you can generate instructions. So imagine you have a use case, but you don't have inputs yet. So you don't have prompts. You can use this task to actually generate inputs for you. And this is really cool because you can define like a set of topics that you want to cover, like mathematics, physics, and so on. And then you will say, okay, my AI application is about generating tables. So with these two inputs, you can actually generate the instructions that we see at the bottom. For example, could you create a table to summarize different types of polygons and properties? So this is a very powerful way to actually generate a first instruction data set and then do the preference data generation. And something that is a work in progress is critique. So I don't know if you've heard of critique, AI critiques. And in this case, it's very similar to the preference data sets, but the LLM will be judging only one response, and it will say, okay, this response fails to follow the instructions of the users, or is not helpful, or is harmful, and so on. So this is also very useful for also RLHF, DPO, but also for automatic evaluation or even data curation for supervised fine-tuning. Yeah, that's it. Are there any questions or comments? Okay, so then I think, Gabri, you want to do a demo?
Yes.
There's one question.
Okay, cool.
About the fact that you stressed the importance for RLHF, and everyone is curious to hear what everyone thinks on about this, given the deployments in the market, and perhaps why Argila thinks this is an important factor.
Yeah, I think we are still very early in the process of seeing what's possible with RLHF outside the work from Anthropic and OpenAI. So I think they really show that this preference tuning, even beyond RLHF, is really important to make sure these models work and are helpful for everyone. So I think that there's no doubt that this stage of preference tuning is really important, because that's one of the key drivers of the success of, for example. But in terms of maturity for outside of these companies, we don't see a lot of maturity. But in these past weeks, we've seen very powerful models, open source models trained with this technique, and namely Zephyr and Tulu, as I mentioned. So those works show that if you go beyond supervised fine-tuning, that is essentially just inputs and outputs for fine-tuning, and you go a step up and you do the preference tuning, you get much more control outputs. So for example, if you are going to use this for, I don't know, translation or generating structure outputs and so on, you can really align the model or steer the model to do very precisely what you want. So I really believe that this stage is important. And what I think is that we lack the methodology, we lack experiments. Those are starting to happen. And as Argila, as a company, we want to be part of that, and we want to actually show how you can really scale these RLHF and AI feedback and human feedback pipelines.
Cool. I think that answered the question. Or does anyone else have an opinion about this? And maybe Gabri can go next, and I'll actually share the notebook for this, so that you guys can actually follow along with Gabri. It's a Google Colab notebook, and I think it should be able to run, in parallel with what Gabri is doing. And we also introduce some intermediate uploads of the data sets that we generate with OpenAI, so that you don't need to incur these costs yourself, and you can actually reuse those. And a request from Danny to maybe upload the Hacker News link he shared to get outreach for our package.
Okay, so I think that I can start, right? Okay, so first of all, I will briefly introduce myself, because I think that I didn't have the chance yet in this community meetup. I'm Gabriel. I joined Argila 6 months ago. And yeah, during this time, I've been collaborating in the Argila core, in the backend, and also the Python client. And yeah, more recently, I've been working on this new framework or Python package, Distilabel. And yeah, I'm really excited about it. And hopefully I can transfer that assignment to you too. So yeah, I prepared this notebook showcasing Distilabel. And yeah, before starting, we just published Distilabel on GitHub. So you can go to the Argila.io profile on GitHub. And yeah, if you like Distilabel, you can drop and start. That will help us a lot. We also have some basic documentation for Distilabel that you can add. And yeah, and finally, if you want to keep up to date with the latest news about Argila and also Distilabel, don't forget to follow us on Twitter and also on LinkedIn. And okay, let's go to the fun thing. Okay, so in this demo, we will use Distilabel to prepare a dataset for preference dataset, which we can later use to train the reward model needed for HF, or even better, to use it for fine-tuning an LLM with direct preference optimization, as Hugging Face H14 did with Zephyr. And for that, we will need almost no data. The only thing that we will need is some ideas about topics. We want to fine-tune our LLM. And yeah, so what we will do is to use Distilabel to first create a pipeline for creating some instructions using self-strat and GPT 3.5 Turbo to generate instructions that later we will use in a second phase and with another Distilabel phase, Distilabel pipeline, to generate some tests using, again, GPT 3.5. Finally, this test that we have generated, we will again evaluate it with GPT 3.5. And we will ask it to give us a score and a rationale behind each test generation that we can use for building our preference dataset. Okay, so first of all, the only thing that you need for running this notebook is an OpenAI account and an API key, which you can directly paste here or even if you want, you can use this new feature that was introduced in Google Colab a few weeks ago that allows you to create secrets that you can reuse in your notebooks and will also help you to not leak API keys. And yeah, and after that, we will need to, of course, install Distilabel. It is published in PyPy already, so you can just run the pip install command to install it. In this case, we are going also to install a few. We are going to install the OpenAI and the Argila extras because we need both clients. We will need both clients later. Okay, as I mentioned before, the first phase or for generating our preference dataset is generating instructions. We don't have instructions. We just have some topics that we want to generate instruction for. So what we are going to do is to create a task, a self-instruct task. And this is not related with Alpaca because this self-instruct task, the only thing that it is doing is defining a prompt template for generating instruction given an app description and some inputs. Yeah, the first thing that we are going to do is, sorry, I said the task, but is creating the dataset that we will need. For that, we have created this list of math topics. As you can see, algebraic expressions, probability, calculus, integration, many math topics that we will put in a Hugging Face dataset. It is worth saying that the Hugging Face dataset is the main structure that Distilabel use for providing the input and also the output. And next, what we will do is to create a self-instruct task, as explained before. And what we are going to do is to describe our application. In this case, we are telling the LLM that we will use that it is an AI assistant and that it has knowledge about math, about logic, about reasoning puzzles, and that we want it to generate some instruction given a list of topics. Okay, yeah. As we can see here, we have created the task. And something important about task in Distilabel is that they expect some input argument names and they will also generate some output. And we can see this using accessing the properties input arg names and output arg names. In this case, the self-instruct task will need an input name input. That's why here, when we created the dataset, it has a column called input, and it will create another column called generations. Okay, after we have defined our task that will guide the LLM, we have to create the actual instance of the LLM. In this case, we are going to use GPT 3.5 Turbo. So for that, we have to use our wrapper in Distilabel, the OpenAI LLM wrapper, and we will pass the instance of the task that we have created before. We will also tell it to use 8 threads to call in parallel OpenAI API, and that we want tests that have 1024 new tokens. Okay, after we have created the LLM, the final step is creating a pipeline which will orchestrate the whole generation process. In this case, we are only passing a generator, but you can also pass a generator and a labeler, as we will see later. And what we can do now is trigger the generation process. Maybe I can retrigger it. This happened to me before, that the messages are not being displayed, but it is running. Okay. Yeah, as you can see, it appeared for 1 second. So this is like a Google Colab glitch. But okay, we will ignore that for now. And after it has finished, we will have a Hugging Face dataset that we can process. And as you can see here, in 2 minutes, I remember that it was 2 minutes, it generated us 4,600 instructions. And here we can see a few of the ones that it has generated. Describe the concept of related rates in differential calculus and provide an example problem to solve. How can I determine the length of a chord in a circle if I know it's distant from the center of the of the circle. And as you can see, it has generated many different instructions that we can now use to generate tests calling another LLM. One thing that we can do is to put this instruction in a Hugging Face dataset, and we can push it to the Hugging Face hub. This dataset is already in the Hugging Face hub, just in case you want to use it in this notebook and you don't need to execute all these files, because it will take a bit and it will also incur costs in OpenAI API. If you want, you can just use this one directly. And okay, we have reached the second phase of our demo. Now is the time for creating the preference dataset using the instructions that we have generated. For that, we are going to create a new pipeline, a new Distilabel pipeline, this time with a generator. We will use again OpenAI LLM, but this time we will use the test generation task. And what this task will do is what you can do with ChatGPT. It will ask the LLM to generate tests given an instruction. And we are going also to create a labeled LLM, again using OpenAI LLM and using the ultra feedback task. This task is implemented using the description in the ultra feedback paper. So it will use the prompt from the ultra feedback paper to rate the generations given by another LLM. And it will basically tell us how good was a generation between 0 and 10. Okay, so we load the dataset that we have created before. And the first thing that we are going to do is to create the generator LLM. We are going to create an instance of the test generation task. And in this case, the test generation task offers a feature called principles. And what this feature does is that at runtime, we will inject one principle in the prompt that will guide the LLM to generate tests focused on a certain matter like harmlessness or helpfulness, truthfulness, honesty, or verbalized calibration. And we can define the distribution of the tests that we want to generate. So in this case, we are telling it, okay, I want 40% of the tests generated to be focused on harmlessness, 20 on helpfulness, and so on. And this is very useful because what will allow us is to get a more heterogeneous data set with more diversity in the test generations. Again, we are going to create an instance of OpenAI LLM, and we will pass the task. In this case, test generation. We will use 8 threads to do 8 parallel calls to OpenAI API, and we will ask it to generate 1024 new tokens. Okay, the next step is creating another LLM, but this time for labeling the generations given by the generator. And what we are going to do is to create a instance of the ultra feedback task, and we want to rate how good the LLM followed the instruction. So we are using this class method for generate a task for instruction following. And again, the same. We want 8 threads and 1024 new tokens. Finally, we create the instance of the pipeline with the generator and the labeler, and we trigger the generation of our dataset. In this case, for the sake of the demo, I just selected 100 samples because, as you can see here, it took around 4 minutes to run, and we are asking it for each instruction to generate 3 tests. So if we pass the entire dataset, it will take around 2 hours. So for the sake of the demo, I just selected 100. And okay, when it finishes, we will have a dataset that will look similar to this. As you can see here, the names, we have all these columns the input, which are the column containing our instructions, the generation model, indicating which model we have used for generating the test. In this case, it was GPT 3.5. The generation prompt that was used for each test generation. Also, we save the raw generation given by the LLM, just in case. Then we have the generations that were generated by our generator. And then the same for the labeler. We have the name of the labeling model, the prompt that we gave it, the response, the raw response that it gave us, and also the rating and the rationale. Yeah, for example, if we take the first example and the generations, maybe it's better to do, and I will also print the extraction. Okay, so the extraction was what is the significance of graph theory in computer science and network analysis? And yeah, okay, now it is better. And the first generation was graph theory is a fundamental field in mathematics that has blah, blah, blah. We have a second generation, which is slightly different, and we have a third generation, which is also slightly different. And then for this generation, we can see the ratings that the labeling model gave to each generation. Sorry, it is rating. For the first generation, a 4 for the second one, and a 3 for the third one. And we can also check the rationale behind these scores. This one fully aligns with the task goal of restriction. It provides a comprehensive explanation of the significance of graph theory in computer science and network analysis by discussing multiple applications, how they are relevant in each area. And yeah, we can see the rationale for the other generations. Okay, so what we have achieved is to create a reference dataset with almost nothing. We just had the topics, and we achieved to generate a synthetic dataset that we can now use for direct preference optimization or for training a reward model. And something that we want also to emphasize with Distilabel is that it is compatible with Argila, or it is integrated within Argila. What we can do is to connect to our Argila server, export our dataset to the Argila set format, and push it to Argila to actually see in a better way the generation and the ratings and the rationale that our generator and labeler LLM generated. So that's what I've done, and we have here the math preference dataset that we have generated. And as you can see here, we can read the instruction, the first generation, the second generation, and also the third generation. And here we are using a cool feature that Argila have, which are the suggestions for setting which rating was given to each generation, and also to show the rationale given to each generation. And something that is also quite useful is the metadata that it is automatically generated. For example, we can sort by the rating of the given to the first generation, in this case in descending order. As you can see now, the rows are sorted by the rating given to the first generation, and we can quickly evaluate here how good are the test generation, and also how good was the rating given by the labeler. And something that we also found very helpful is to create some other metadata properties. For example, we could generate one metadata property that give us the difference between the ratings, for example, between the first rating and the second one or the third one. And this could help us to quickly identify special generations or even flaws in our generation process. And in fact, this is what we did when with ultra feedback dataset, and we detected that it had some bugs in the pipeline code. And yeah, we generated a new version of this dataset, and hopefully soon we could also release something cool that we have in training. And yeah, I think that's all for Distilabel. We will continue in the upcoming working in the upcoming month to bring more features to Distilabel. We have in the roadmap the critic task that Danny mentioned before, but also some other features like using a pool, several models for generating tests, so you don't have to use the same model. And yeah, as I said before, if you want, you can follow us on Twitter, on LinkedIn, and to keep you updated about the upcoming developments that we will do in Distilabel. And that's it. Thank you so much. And I don't know if you have any question.
Cool. Thank you, Gabby. And I think if there are no more questions, then we will wrap up the bi-weekly. And we hope to see you during the next one in 2 weeks. And that time, I think maybe Natalia was going to present something about managing annotation teams and setting up workforces for LLM labeling. So that's going to be exciting. And we hope to see you all there. And thanks for coming this time. And also thank you to Danny and Gabby for presenting, of course.
Thank you, everyone.
Thank you so much.
Bye-bye.
Thank you. Bye.
See you.